This is John Black, Super Chemist. I reformatted my computer and now I don't have an editor, so I gotta kind of, this might not be the best video because I can't edit out when I stutter and stuff. But anyways, it's another computer program or computer site. I have two videos up about two different computer sites already. One I thought would do super well, and it's not doing that great, so I'm going to mention it. It's where you plug in any chemical that you want, and say sodium acetate, or methylbenzene, benzene, or whatever. And whatever you type in, it'll spit out 1, 10, 20, 100, it depends on how many products have it. But it'll spit out a list of products that you can buy at the store, like Lowe's, Walmart, whatever, and it'll tell you the percentage of that. Let's say I want benzene, so I say benzene, and then let's say it kicks out 10 different products. On the side of each of the products, it'll tell you what kind it is, like liquid, aerosol, what is it, and the percentage. So you just look at the high percentages ones, you know what I mean? If you see one that says 30%, you click on it, and it'll give you the MSDS of that product, meaning all the ingredients that are in there, and you can see if you can extract it out or not. If not, if it's too hard, go back. Go to the list and look down and get another one that has a big percentage. Another one might have 20, maybe 50%, whatever. Click on it and see if you can extract it out of that. The other computer site I had was an azeotrope database type thing. You can plug in 2 or 3 chemicals, and then it will tell you if they form any azeotrope or any ternary azeotrope. It doesn't just do binary azeotropes. If all 3 of them form a ternary azeotrope, it'll tell you. Not only that, it'll tell you the azeotrope boiling point. It'll tell you the composition, meaning the ratio of all the different components, either by moles, mass, volume, whatever you pick. You know what I mean? Just like the degrees. You pick Fahrenheit, Celsius, whatever, Kelvin. So that's the second one. This is my third one. Now this one is about a nomograph. And I have a picture of a nomograph up there. Let me show you how to get to the site first. I'll try to put it in the description, but if that address I put in there doesn't work, because I'm not good with computers, just follow the instructions, because this is how I get to the site. I never just punch in whatever. What I do is you can see up there it says Sigma Aldrich Nomograph. I punch that into Google. Top 2 ones will be the same thing. The one that says Sigma Aldrich Nomograph, that's the one you click on. And it'll go to this, what I'm showing you on the screen right now. First one there says new boiling point. Okay, that would be your boiling point under your, because what a nomograph is it tells you the boiling points of liquids at different pressures. Normally a vacuum at a different lower pressure. Now, you can plot them on there. Let me see. This is your new boiling point. This is your boiling point at atmospheric pressure, and this is your new pressure. Okay. Well, let's say I had 10 millimeters of mercury. See right there, and I was doing 100 degrees Celsius as a boiling point. Okay. So all you do is you draw a line. You plot your two, plot it here, and then you get a roller, and you draw a line so that it goes, and it will come down here. Now I just made this up. This isn't perfect, so my numbers are wrong, but it's just to give you the gist. See, now if I go like that, I can see it will boil at 0 degrees Celsius at 10 millimeters of mercury. Now you can print this out so that it's an exact copy, whereas mine's just, I just hand drew that. And you can use your roller, and you can do it. You're never going to get it perfect. If you go to the site, you just punch in your boiling point and your pressure. You lock them, and it will draw a line and tell you down at the bottom the exact new boiling point to the decimal. to the 10th of a degree. So that's what's nice about this. You don't have to think. You don't have to get a roller. You just go to the site, punch in your new vacuum, right? And this is a good way also to find out how good your vacuum is. If you don't have a gauge, like I just get a vacuum pressure gauge. They're only like $5, and I, put it into the system so I can see. But if you don't have that, you want to know what your pressure is. What you do is you distill some water, okay? Water boils at 100 C, so you can plot that, right? And then you put your vacuum on and you distill the water, and you see what temperature does it come over, right? Your new boiling point, right? You plug that in, and then you lock those, and it'll draw a line to wherever the pressure is, and then you'll know your pressure. I mean, like according to this, let's say that it was boiling at 0 degrees Celsius, and it normally boils at 100. You draw your line. We already saw that it went to 10 millimeters of mercury. Now that isn't right, because this isn't, I didn't print this out. I just drew this by hand. But if you were on a computer, you'd know exactly what your pressure was on your vacuum gauge, right? And then you can always, when you get, you got a new thing, you always put in 10 millimeters or whatever it is. Whatever, if it's 25, I think mine goes down to 25 microns, which is 25 millimeters of mercury. So I'd plug it into here, down here. You can text it in, 25, and I'd put my boiling point of whatever I was boiling, and it would tell me what the new boiling point is. So I would know exactly how to boil, what temperature to boil it at, to get my product out, my chemical that I want. I think that this is good. All three of these are great sites for, if you're into chemistry. I have more sites coming, but now that I'm working a lot right now, I can't really do experiments, so I'm trying to get some easy videos up. So if you don't know about the other two computer sites, go check them out. They're great if you're looking for chemicals in products at the store, or you're trying to extract stuff out and you don't know if they form azeotropes. There's a lot of things that form azeotropes that you don't realize, and if you don't take that into consideration when you distill stuff out, you're not going to do it right, because these azeotropes will mess things up. Anyways, y'all have a great day, and always remember, science is great.